So now, let us look at media access control part. So some of the information in the slides already being explained in the previous week, because in lecture 3 I already explained about the forwarding methods concept in a switch. So this is kind of like recapping again what you have learned earlier on. So switch use one of the following forwarding methods, which is store and forward switching and also cut through switching. So in store and forward, what happened here is the frame forwarding. It is a frame forwarding method that must receive the entire frame and perform error checking, which is the CRC computation. So if the frame is error free, then the frame will be forwarded to the destination. In cut-through switching, so the frame forwarding method will forward the frame before it is entirely received. So basically, the minimum information that the switch needs is the destination address of the frame. So once it gets the destination address of the frame, so basically it will just forward it without performing any error checking. So the advantage of the store and forward is, first, there is error checking before frame forwarding, and second, it will reduce the amount of bandwidth consumed by corrupt data. So by default in Cisco devices, so they use store and forward switching. So it's very important for the quality of service on a converged network. So in cut-through switching, there is two types of cut-through switching, or two variants. The first one is fast-forward switching, and the second one is fragment-free switching. So fast-forward switching is the fastest switching type, because in fast-forward switching, so you can start forwarding before the entire packet has been received. But because of this, there are times when the packets relayed in the network are a packet with errors. So basically, to improve this, so we come with fragment-free switching, which is at least the switch or the frame must perform error check on the first 64 byte of the frame before forwarding. So this is to ensure that a collision has not occurred before forwarding the frame. Now, besides frame forwarding technique, so we also have memory buffering technique on switches. So the Ethernet switch use two main buffering techniques to store frame before forwarding them to the destination. So the first technique is port-based memory, and the second technique is shared memory. In the port-based memory, so basically frames are stored in queues that are linked to specific incoming and outgoing ports. So basically here, a frame is transmitted to the outgoing port only when all the frames ahead in the queue have been successfully transmitted. But in the shared memory, all of the frames will be deposited into a common memory buffer which is shared by all switch ports, and the amount of buffer memory required by a port is dynamically allocated. So basically, for port-based memory, basically in each port, incoming and outgoing port, so there will be a specific queue or specific buffer. But for shared memory buffering technique, so all of the frame will be stored in a common memory buffer which is shared by all switch ports. So the shared memory buffering results in larger frame that can be transmitted with fewer drop frames. So this is usually the asymmetric switching will use shared memory buffering because it allows for different data rates on different ports. Now, I would like to talk about when we talk about switch speeds and for the method, so I would like to talk about the duplex and speed settings. So the two of the most basic settings on a switch are the bandwidth or the speed and duplex setting for each individual switch port. So basically there are two types of duplex setting used for communication on an internet network, which is full duplex and also half duplex. For full duplex, both ends of the connection can send and receive data simultaneously, and in half duplex, only one end of the connection can send at a time. So auto negotiation is an optional option found on most switches and network card. In auto negotiation, so it enables two devices with two different duplex and speed setting to negotiate the best speeds and duplex capabilities. So if the port is a gigabit Ethernet port, so they can only operate in full duplex. But if it's a fast Ethernet port, so it can operate in both half duplex and full duplex. So for example, in the diagram, you can see that when PCA has both full and half, so it will negotiate with best duplex method. Okay, and for the speed, like for example, a port can offer speed up to 1000 megabit per second, but for the PCA, it only offers speed until 100 megabit per second. So the auto negotiation will only negotiate the best for both, the best speed for both, which is 100 megabit per second. So the duplex mismatch is one of the most common causes of performance issues on Ethernet links. So it occurs when one port on the link operates at half duplex while the other port operates at full duplex. Like for example, if a switch which can operate at maximum full duplex is connected to hub which can operate at maximum half duplex, so basically duplex mismatch will occur. So what happened here, as a network administrator, you have to set the switch to half duplex, and the hub, of course, they can only be set to half duplex, so that both devices can talk to each other. So now, duplex mismatch occurs when one or both ports on a link are reset and the auto negotiation process does not result in both link partners having the same configuration. So it can also occur when user reconfigure one side of a link and forget to reconfigure the other. For example, in this case, we have two switch 1 and switch 2. So basically, switch 1, by default, the port is set to full duplex. But the user, the network administrator, reconfigure one side of a link as half duplex, for example, and forgot to reconfigure S1 as half duplex. So even though both sides of a link should have auto negotiation on, but if the network admin manually configure the duplex setting differently, so basically duplex mismatch will happen. So because of this, we have the auto MDIX. So what is auto MDIX? Auto MDIX is automatic medium dependent interface crossover. So what is the function of this feature? So basically, the MDIX feature is very useful as when you enable it on a switch. So it will automatically detect the type of cable attached to the port and configure the interface accordingly. So basically, in this for example, um, let me see if we look at the figure. So for example, this figure identifies the correct cable type required to interconnect switch to switch, switch to router, switch to host, or router to host device. So basically, like what you learned usually, okay, so if the device is of the same type, so we use the crossover cable. And if we are connecting device of different type, so we use the straight through cable. So because now we enable the auto MDIC, so you can use either a crossover cable or straight through cable regardless of the type of device on the other end of the connection. Like for example, supposedly like what you learn in data core, so you are supposed to use crossover cable between two same device, but actually if you enable auto MDIC, so you can use a straight through cable to connect to the same device because we already enable it with auto MDIC. So the auto MDIC features is enabled by default on switches that run Cisco IOS. However, this feature you can enable or disable. By default, it is enabled, but you can also disable it. Okay. So for this reason, you should always use the correct type of cable and do not really rely on the auto MDIC feature. But as you always practice in the lab, the auto MDIC features is already by default enabled on your switch or on your routers. So for the half duplex communication, it only allows one device to send or receive at a time on a shared medium. So it is usually used in wireless LAN and legacy bus topology with Ethernet hubs. So you have to know that if you were given a network with a hub, so if you have a hub, if you have a switch in the network topology, so basically once you have the Ethernet hub in the network topology, regardless how many switches that you have in the network topology, so all of the switches need to be set to half duplex so that it could communicate with the hub. Otherwise, what will happen? Duplex mismatch will happen. For the full duplex communication, it allows both devices to simultaneously transmit and receive on a shared medium. So if the network topology consists of all Ethernet switches, so basically all of them can be operated in full duplex mode. And then we have the access control method, which is contention. There are two types, which is contention-based access and also control access. So basically, I think I have explained earlier. So if the devices operates in half duplex, so basically collision will happen. Because of why? They are competing for use of the medium. So to avoid this, so we need certain method. This has been mentioned before. We need certain method. So in bus topology Ethernet, or if you are using the hub, so we will use the CSMA CD method. In the wireless LAN, so we will use the CSMA CA method. So there are two methods. If we want to avoid collision in hub environment or bus topology LAN, So basically we will use this CSMA-CD. But if you want to avoid collision in the wireless LAN, so we use the CSMA-CA method. Now, for control access, control access can be implemented using deterministic access where each node has its own time on the medium. Okay, so all of this is the technique to what is access control method? This is the technique to avoid collision, collision in the network when the nodes is operating in half duplex. So there are two ways, which is called tension-based access, and also we can control the frame forwarding and avoid collision using the control access method. So one of the technique is deterministic access, where each node has its own time on the medium, and it is used in the token ring topology. Now, in the CSMA-CD technique, so like I said earlier on, it is used for hub-based bus topology or hub-based network. So in the CSMA-CD, it uses a collision detection process to govern when a device can send and what happens if multiple devices send at the same time. And in the CSMA-CD collision detection process, so first, the devices transmitting simultaneously will result in a signal collision on the shared media. So when the device detect the collision, so they will wait for a random period of time and retransmit the data. In the CSMA-CA, which is the technique that is used to avoid collision in wireless LAN, so the process is when transmitting, devices also include the time duration needed for the transmission. So basically, other devices in the same transmission medium will receive the time duration information, and they will know how long the medium will be unavailable for them. So they will not transmit the frame when other people within the given time duration.